Broadcast is now starting. All attendees are in listen-only mode.
Hi everyone, thanks for joining us. For those who don't know me, my name is Catherine Friend. Thank you for joining us. We have a number of people joined us so far. We might leave it a few extra minutes or so to see if we get any other attendees. But just to give you some background, as I said, my name is Catherine Friend. I am the owner of a company called Chameleon Science. We're a new company and we're specializing in new and emerging technologies. And I have hooked up also with FluoroFinder as their Asia Pacific representative to see if we can increase the use and the market awareness for FluoroFinder. And so I wanted to set up a series of webinars introducing both these new technologies and the new applications that can be employed. And this is the first of I'm hoping many webinars that we're going to run. And I'm really pleased to be introducing Kelly Lundsten from FluoroFinder as our guest speaker today. So Kelly and I have known each other for many years since when we were working in BioLegend together, and I'm really pleased to be working with Kelly again at FluoroFinder. We might leave it just a few extra minutes. Maybe we'll start right on 10:05. So just to leave an extra couple of minutes for people to join us. But just as I'm going to do a couple of bit of housekeeping things. First of all, I don't know if everybody's on mute at the moment, just to kind of make it easier for us to be able to run the webinar. I'm also going to be on mute once Kelly starts, but we'd love to hear from you and we'd love to hear your questions. And I've asked Kelly if she wouldn't mind if you guys ask questions all the way through the webinar, and she would prefer it because, there you go, big thumbs up from Kelly. She would prefer it because it means that the webinar is more interactive. So please do put your questions either in the chat or in the questions box in the GoToWebinar panel. If you can't find it, I don't know, send me an email and I'll probably monitor my emails at the same time. So Kelly, if you don't mind me interrupting you every now and again with a question or two, that'd be great. If anyone's got any further burning questions, as I said, you can email me as well. The other person that you probably might be, that I should probably introduce you to as well, who will be working behind the scenes, is Sophie Kauser. Sophie is the marketing specialist from FluoroFinder, and you'll probably hear from her in terms of marketing emails and marketing content, where she will be in contact with you from FluoroFinder. She's done a wonderful job setting up this webinar, so thank you very much, Sophie. She's in the background here as well, so I wanted to introduce her as well. So maybe 10:04, perhaps we should leave it a minute and start. I would do some hold music if I had some. We do a song and a dance, maybe. Kelly, what do you think?
I'd love to see you dance.
No, nobody wants to see me dance. While we're waiting for everyone to join us, maybe I should just do a quick introduction of Kelly. So Kelly Lundsten, as I said, I first met Kelly when she joined BioLegend many years ago, and Kelly and I did a great job of introducing the brilliant violet fluorophores to the Australian market. And in fact, we did such a good job, I think, that the Australians were ahead of the uptake of the brilliant violet fluors in front for a while there. We were the world leaders of brilliant violet fluor uptake. So Kelly did a great job of touring around Australia and introducing not only brilliant violet fluors, but the whole concept of a fluorophore, and really educating the market about what fluorophores are. And as a result, she's got a really nice following in Australia. So thank you to all who know her from previous from our previous work. So Kelly is actually a subject matter expert in fluorescence chemistry and its application to predominantly microscopy and flow cytometry. She's been in the field for about 25 years, working first of all with molecular probes, then to Invitrogen, BioLegend, Thermo Fisher, and now FluoroFinder. Kelly is always teaching and is currently working with FluoroFinder to develop tools that help researchers plan experiments from end to end. She helped design the content of the new IntelliPanel, which she'll be showing today, which is an automatic panel suggestion tool, and is setting her sights on tools that will help us wade through the biological context of our research applications. Kelly, thank you so much for joining us today.
Thank you for the introduction, Catherine. I want to thank you guys all for coming today. It's a little discombobulating. I can't see anybody, so let me know if I start having a delay or anything like that. I'm going to do a little bit of a lecture just for about 20 minutes, hopefully, and then I'm going to give you a demo for the next 30. Feel free again to ask questions. It's so much nicer when it's interactive than when we're just kind of here by ourselves. So it's kind of a general topic, the principles of flow cytometry panel building. I find that this is highly oversimplified in a lot of talks, and so I'm going to cover a lot of the basic points that we're using to automate panel building. Basically, how it's a lot more complicated than just statistical measures of brightness and overlap. We are on the first phase of an intelligent panel design tool. It is still a suggestion to begin optimizing a panel, but what I like to say is even on an Aurora, it gets you about halfway there because it's able to do some mathematical calculations that we're not really able to do ourselves in our minds at any point, even as an expert. So I'm going to break it down into the different components of panel building, and the first step of any panel is going to be the biological components. Some of this vendors can help you with, some of it experience is the only teacher. Some of it is directly out of the literature. So I'm going to glance over a lot of this since this isn't a full panel building talk and it's not a full FluoroFor talk and it's not even a full demo talk. So if you have any questions about these, again, put it into the chat or you can email any of us directly. So the biological components, the question here that you have to ask yourselves is, what do you need to validate and understand about the biological components of your assay? That would include things like, number one, clone validation. I do a lot of work on the side with people developing OMIPs or just validated panels, and I can't really stress how important it is that we do our own clone validation on our own biology. For simple markers like CD4, CD3, CD45, all those basic sorts of things, obviously clone validation isn't quite as important unless you want to go after intracellular CD4, or probably the best example that I have of this is my own experience using chemokine receptor antibodies. BioLegend was working on their own clones during the time that I was there, and it was just like night and day seeing how different clones could make on your assay. One of the things like with any sort of manual panel builder is then the commercial availability of the fluorophores or the fluorescently conjugated products, you know, the direct conjugate sort of thing. What's difficult right now is if we have to incorporate, what's difficult to automate is if we have to incorporate unconjugated antibodies or biotin conjugation, and we're working on kind of advancing that to the next step. For both of those, well, for at least unconjugated, you have to be able to take into account the isotype and other factors like that. So you have to know a lot more about your biology even before you begin to choose markers. But when I first started 25 years ago, it was actually with molecular probes when Invitrogen was introducing QDOTs. And that was a whole different set of people, usually working on HIV vaccines that were trying to get to 17 to 18 colors using QDOTs. And back then, I used to use a spreadsheet. I would actually make an Excel sheet. I would go to each of the, you know, at that time, it was only a few vendors because there weren't as big of a repertoire of direct fluorescent conjugates as there is now. And I would just populate an Excel sheet with what fluorophores were available and what markers. any sort of manual automated panel builder or, any tool online is going to make that so much easier for you now, because you'll be able to access vendors that maybe are a little less popular but have very specific antibodies. And you'll be able to derive more information about the clones than maybe you would have populated into your own spreadsheet or your own, your own tool. Number two is that you need to know each marker that's needed in the panel. And one of my biggest pet peeves in the industry is that a lot of times we can go to a paper to derive panel information and say, oh, I want something that's really similar to this, but maybe there's slightly something different about my panel or my needs than what's represented in this paper. And I really want to bring people back to what a definitive phenotype is. So for those of you who aren't uber dorks in flow cytometry like the rest of us, there are a lot of behind the scenes standardization committees within the International Society for Analytical Cytometry. They're called ISAC, and it's a meeting that a lot of us attend regularly. It's an overview of technology and reagents and things that are advancing within cytometry. And within that cohort, there's all these subgroups that are trying to standardize things like definitive phenotypes. So this used to be something that we would actually argue about. Do you use CD45RA or CD45RO? Or, there'd be like these little questions or ways of getting to a particular subtype or a particular sub-expression group. And in the end, it would be great if we can all agree upon definitive phenotypes for at least cell subsets. And I would say that we're really close to being there, but that you can, as a user, as the researcher, you need to be able to build upon that definitive phenotype. But the purpose of all of this, all of the standardization efforts for how we gate or what markers we use or how we put together panels, is meant to raise what I call the hive mind. So, we don't pour our own gels anymore. Everything that we did when we were younger, 20 years ago, now has become more automated. And there isn't really a reason why flow cytometry and panel building can't be the same through all of these efforts to standardize. And that's where FluoroFinder comes in. We want to be from end to end, from the time that you're beginning and you're determining a lot of these biological questions through the point of what is the standard method of analyzing to get to this particular subset. So that is going to be kind of our future. We're really just on the first phases of a lot of these projects. So you need to know your definitive phenotype, but more importantly, I feel like everybody on the planet should just ask themselves why. Why do we think and do? Why do we build any assay the way that we do? To understand the purpose of each of the markers in your panel and have a validated gating strategy that makes sure that you don't accidentally negate or underrepresent a particular cell population is really important. And some of that you can get from the literature, and some of it you can get from using more advanced software, things like VISNI and TISNI, and they're called dimensionality reduction software. And what that helps us understand are, what did we lose when we shut down or we limited how we gated towards a subpopulation? Was there anything that we missed because we were tunnel minded in believing that we understood where our biology was going? Third is how activation, cell health, disease, or treatment affects antigen density. And antigen density and fluorophore brightness, that's something that you'll hear regularly when people are giving you panel development talks. One thing that I want you to think about that is kind of taking that to the next step and something that we intend to automate is, what is the expression pattern? How we choose fluorophores is not just whether they are abundant and whether or not the fluor is bright or not. It's also what kind of expression pattern does that have? For example, if you have CD45RA versus 197 and you have all of these transitional events that are going in a distinct pattern across that plot, those kinds of markers need to be on fluorophores that really have minimal spillover, and also sometimes are at the end of the spectrum. Or so I would say in those instances, often I will use fluorophores like, not just for that instance, but fluorophores like FITC or BV785, because they, in their variability of how much is expressed and how it's expressed, it's going to interfere with other channels less, because neither of them have a particularly strong spillover pattern into other channels. Another thing that we often don't think about is the prevalence of that cell type. There is an effort that's going on for forever, for easily over 10 years. I don't even know when the first paper was published, but you can go look into it, or I can send you the link. But it's an effort by the HCDM, which is the consortium that determines which antigens receive a cluster of differentiation, or a CD name. And it helps us make sure that we don't have redundancy, that the antigen is validated, that it's real. It puts it it tests it by fire. And that particular consortium has been working for a long time on taking all of the CD antigens and putting them into a particular backbone in order to understand how they express on different subsets, like naive B cells, or just general lymphocytes, or B cells, or dendritic cells, or PDCs and MDCs, just kind of the gamut of cell types. So the density with which they're expressed, and then also their prevalence. That prevalence is just as important. There are some markers, like I would say CD123, or different ones where it might be very rare, but the antigen is relatively abundant. And then there's others where not only is it rare, but it's also not abundant. And so those are two things that will determine what kind of fluorophore we assign to that particular type. Once that database is actually made available to everyone, that's going to be something that's able to be automated, at least for healthy human tissue in blood, thymus, and tonsil. But we all have to start somewhere. And so a lot of these things, when it comes towards automation, are really just where we're starting. And then finally, there are markers that are positively co-expressed on an event. That's what we can do right now, is say within this group of co-expressed antigens, there's a certain complexity index. The complexity index is defined as, within that co-expression group, each of those markers is assigned a fluorophore. It is how much each of those fluorophores spill into each other that gives you an idea of maybe what the spillover spreading error might be that might preclude you from being able to cleanly gate on that population. So I know that's a little complicated, but it gives you an idea of not just a single spectral spillover between two channels, but the total spillover between all fluorophores that are on antibodies against antigens expressed on that cell. So there are two different tools that FluoroFinder offers. One is our reagent directory. So this is kind of our antibody search engine. It gives you an idea of, all sorts of, for example, this is STAT1, where there's all these different phosphorylated or site-specific phosphorylated antibodies. It gives you an idea from all the vendors of what fluorophores they're conjugated to, all the isotypes. You can go to their websites, you get the idea. You can sort by all of those features in the middle there, the target, the host, the clone, etc. That lets you know, especially if you have a rare target, that it's in there, that you can include it in a panel, and it gives you kind of more information to explore about that marker. And then there's also what will always be free, the manual panel builder, where it's just a tool to help you organize your thoughts, but you still have to go through and manually choose the fluorophores for each of the markers. And then you can go on to choose the products and create a quote that you might want to send to someone. Okay, so the instrumentation components, there's only a few things that I kind of want to show you here that I think that we'll be able to eventually include in our automation, but that is not today with IntelliPanel. What we can do today is match the fluorophore to the channel. So when you initially use FluoroFinder, it's going to bring up your institution. It's going to have all of the instruments that are in your institution, all of the filters that are associated with them for non-spectral instruments. And what we're doing is taking the total spectral emission of a particular fluorophore and saying we can tell based on its peak and based on its coverage of any one of those filters that it is intended for that channel. One of the elements of instrumentation that I want to make sure that you have clarified is that within every configuration, every instrument that you have, you're going to have a different amount of spectral spillover into each channel, as you've probably known previously by just simply having a compensation matrix. That compensation matrix is easily affected by a change in the balance of all the voltages, whether or not you increase one of them, by 20 volts or, decrease them by 20 volts. It will change the comp percentage just by changing the voltage. But one term that you're going to hear a lot that's most important to us as we go to a higher parameter level is spillover spreading error. And that was well documented in probably the first paper that really did a good job describing this, which was the citation there. It's out of Mario Roederer's lab with Steve Perfetto. And what's important to understand is that spreading spillover error has a direct relationship to the amplitude of the staining or the signal of your marker. So the more abundant your marker is, the brighter it is, and thereby the wider the spreading error will become, which can then sometimes impact your ability to resolve another population. So in multicolor, and I'm not really talking, it's pretty easy to build a panel that's below 10 parameters. Above, 10 to 12 parameters, you start to have factors like this that will impact your ability to build a good assay. Just other instrumentation components, whether you're using PMTs, APDs, PMT arrays, APDs in particular make a big difference between, say, an Aurora and a Bigfoot, or a Cytoflex and a Fortessa. APDs are known within our area of cytometry as being a little bit more efficient beyond 700 nanometers. These are the challenges between instruments of transferring your panel. Why we will continue to say that you have to optimize, because we don't have a way of doing a calculation for the changes in detector efficiency quite yet. Although I would like to see that in the future, because it is possible. It would require each of you to characterize the complete sensitivity and efficiency of your instruments in order to incorporate it, and that has to be done for every single instrument in your lab. So I think you can understand the difficulty probably in just even collecting that sort of information. Other things that you probably know impact the kind of success or the sensitivity of your assay are your flow rate, your speed, and in this case, for sorting, your nozzle size. Slower tends to be better in terms of the standard deviation of the emitted signal, the range. And I don't know many people that don't run at super high rates, because we have to sit there for so long typically to get through all of our samples. So if you are having a loss of resolution between two populations, slowing down your rate can sometimes help with the total spread of the emitted population cluster. And then finally, specific wavelengths and wattage of laser excitation sources, which is actually the bottom. I have been working for the last few weeks on our database, because programs are only as good as the quality of the database. And I want to make sure that we're always having very well curated information that is standardizing fluorophores, trying to take into account the user experience on the different sensitivity of instruments. So just as an example, being with a fluorophore person for a long time, normalized spectra has always annoyed me. We only use normalized spectra where each peak is brought up to 100%, no matter what its brightness is or anything like that. And we did that, especially in microscopy, to match filters, to say this filter is more optimal for this particular fluorophore, because they can often shift even just by 5 to 10 nanometers, and it can make a difference. So the middle plot there, and what we're looking at is Alexa 647, Alexa 633, and the APC. And right now, the BDA5, which is one of the most high parameter standard non-spectral instruments out there right now, for some reason, they have a 628 laser. However, the filter is ideal for Alexa 647, even though Alexa 633, which molecular photon to photon or structure to structure is equally capable. It's as bright as Alexa 647, but on this instrument, the 628 laser is more optimally exciting Alexa 633, even though the filter is centered around Alexa 647. I don't know why. I don't work for BD. And then there's other instruments like the Beckman Coulter Cytoflex, where they obviously are very directly targeting APC. They shut down the filter because APC is a very bright fluorophore. Most would consider it to, on a scale of 1 to 5, to be between 4 and 5. And so they shut it down to only a 10 nanometer bandpass filter. However, it's directly at the peak of only APC. So actually using Alexa 633 or Alexa 647 on the Cytoflex with this particular laser may not necessarily be your best choice. So on our SpectraViewer, you're able to do exactly what I did here, which is choose the particular laser in order for it to represent from 100% what the diminishment was due to a loss of efficiency due to that laser line. Eventually, that's something that I want us to incorporate into IntelliPanel as well in order to affect the overall brightness that we assign to the fluorophore. All right, so reagents. This is my favorite part. What do you need to understand about your reagents? I put a little graphic up here because what you'll hear a lot of people like me talk about are fluorophores that are either the culprit or the victim. And the culprit fluorophore is the one that is spilling into another channel. The victim tends to be the channel into which it spills. That channel is usually assigned to a particular fluorophore. So for example, Percy Psi 5.5 would be the culprit spilling into Alexa 700's channel. And thereby Alexa 700 would have to be very bright to overcome the spillover that happens in that instance. So what do you need to understand about your reagents? Something that is integrated into these panel development tools is the brightness of any particular fluor. But that brightness does extend to then the antibody conjugate itself and then the event itself, which is a culmination of the expression level of the antigen. Second are probably the thing that is most confusing are what fluorophores are equivalent products despite their commercial naming. This has happened pretty significantly in the last, I would say, 5 to 8 years because a lot of fluorophores went off patent. And so everybody was able to take those structures, get them manufactured and put their own commercial name on them. However, they still remained identical products. They are identical fluorophores just with different names because of the different manufacturers. So that's actually something that I'm going to incorporate into what we call our dye directory, give you a list of everything that is the actual equivalent, equal, same product, and those that are unique. For example, if they're pegylated or Miltenyi has a multimer system or things like that. Third would be, how are you going to use that antibody? Is it intranuclear, intracellular, cell surface, or phosphospecific? Each of those is going to impact a fluorophore differently. If you're using an intranuclear buffer, especially if you're using a phosphospecific buffer, it has the potential to degrade your fluorophore. Fourth would be that you have to consider any nonspecific binding actually due to the fluorophore. So this is why we recommend things like monocyte blocker and brilliant staining buffer. Both of those should be used if you're using more than one brilliant violet, especially if it's 421 and one of its tandems. And monocyte blockers, just generally, it doesn't hurt anything. Neither of these hurt anything. They will only make your assay cleaner. So I would highly recommend using them all the time. And then an identification of which fluorophores are the culprits and which fluorophore or channels are the victims. So below here, this is probably one of the best staining index charts that I've seen. It does on a 1 to 5 scale, which is the most common. But I do want to impress upon you that these cutoffs between dim or moderate or whatever, they were all done simply by a person that looked at these values and said, this is where I'm going to make the cutoff. There's no standardization of brightness in the industry whatsoever. And the brightness index is going to be integrally affected by the differences between each instrument. So sometimes people have been doing CD4 performance assessments where they take blood, they label with a single fluorophore for each of the channels that they have in order to say, you know, this is Pacific Blue versus BB421 in this channel. What is the performance on this instrument with these filters, with, you know, these APDs or these PMTs? The plots that I have on the right-hand side are something that I actually derived while I was at BioLegend when we were releasing the TrueStain monocyte blocker. This is actually not even a cyanine dye, which is a common misconception, is that only Cy dyes or their tandems like PE Cy 5 are non-specifically binding monocytes. So the bottom you can see having no blocker or having just FC blocker, and this sort of non-specific binding is usually on any antigen presenting cell, so activated B cells, monocytes, whatever. And then having the buffer just kind of brings that back down. And what we don't want to see is that people think that the CD14 positive that is going beyond the negative gate for CD19 is somehow a co-positive population. All right, and I'm just going to kind of leave you with this because we need to move on to doing the demo, but I'm starting to kind of create this which fluorophores to choose based on if you've ever seen a risk assessment, something that it is a very strong culprit. Something like per-CP Sci 5.5 is probably the strongest culprit. Oh, actually, that's not true. PE Sci 5 by far is the worst culprit into APC because Sci 5 is Alexa 647. They are the same, basically the same molecule. And PE Sci 5 is very bright versus per-CP and per-CP Sci 5.5 are actually very dim. So this just does this kind of matrix of fluorophores that are dim and also completely innocuous, like Pacific Blue, Alexa 700. These dyes, they don't spill really into much else. So you can consider them to be relatively innocuous, but they're also really dim. So they're simply not populating a lot of photons into that spillover. And then we kind of progress along the bright, but also innocuous. Those would be like FITSI, well, actually FITSI's not very bright, but BioBright 515. If you haven't tried the BioBright dyes from Miltenyi before, I really recommend them. Also the Starbright dyes from Biorad, they're all alternatives to the Brilliant Horizon dyes. They use different ways of multimerizing. Some of my favorites, PE Dazzle or CF 594. So I'm just gonna kind of leave this with you. It's in the PDF handout for this talk. I'm gonna, I think, eventually make this into something that's easier for us to reference because it's probably the #1 question that I get from people when I'm teaching is I simply don't know the difference between the fluorophores in order to choose them for the right application or for the right marker. And I totally get that. I've been working with fluors my entire career. So that's second nature to me. We have to figure out a way to make it easier to access. Okay, so these are my pups. This is Montana. If you've never been, it's absolutely gorgeous. If you have any questions or you want to request a demo, you can contact Sophie or you can contact support@fluorofinder.com, which goes to our whole team, including me. Or again, ask a question in chat because I'm going to set up the, I'm going to set it up in order to show you a demo. Oopsie, that's the GoToWebinar.
So can I put it to everybody else who's out there at the moment? Do you have any questions about, so general questions about panel design, fluorescence intensities, how to set up, you know, a nice panel? Is there any other questions now on the content that Kelly's put together before we show you through the IntelliPanel system?
Yeah, we definitely glossed over a lot.
I know, we
usually each of these could be their own 1-hour seminars. So, and maybe we'll do another one with Catherine. Okay. Can you guys, Catherine, can you see the web page?
Yep, we can see the IntelliPanel web page. So, guys, again, the questions, I can just show you where we can put the questions in. Actually, let me just see if I can write a question in.
Okay. Are you okay for me to start, Catherine?
Yeah, just want to make sure that if everybody can send questions if they need to, or alternatively, just message in the chat.
Okay. We don't have a ton of time, so I'm going to get started.
Sure.
This is actually a redesign recently. I've been learning a lot about programming that I've never known or had a reason to know my whole life. I wouldn't even say it's programming. It's more just like design of these tools is pretty crazy. And recently we implemented FluoroFinder 4.0 to make it easier for us to adapt to changes in kind of tool development. And we've been developing so much, we need a better organization system. So we kind of correlated this with the launch of our IntelliPanel. IntelliPanel does require a subscription or a site license or something like that, but it's outrageously inexpensive, especially for academics. It's kind of the first time that we've ever had a subscription model at all. So the manual panel builder of course will always be free, and many elements of this are free. The spectral viewers are free, all the directories are free, you know, that sort of stuff. The training is now integrated into FluoroFinder 4.0. We use the workflow training that was developed by Sebastian Kokri at Regeneron. It isn't just lectures, it actually takes you step by step through the training, and that's included in FluoroFinder 4.0, which I was extremely excited about. Training is one of the hardest things in flow cores to stay on top of and not have it be really redundant all the time. So we're going to go into the panel builder. The conventional flow cytometry, that's the manual panel builder. We also have spectral flow cytometry. This is also theoretically a manual panel builder. IntelliPanel, this is just helping you organize based on the different specifications of spectral instruments. But the IntelliPanel is the one that I'm going to show you. And one of the best times career-wise that I ever had was meeting with probably 15 grad students at the University of Otago. So I like to use, for this crowd, University of Otago as an example. It's going to automatically populate any core facility that's registered with us. If you don't see your institution here, it's because they haven't contacted us to register the institution or the facility or their instruments. And that is super easy to do. You just click right here, add your institution, fill out your contact info. You need to be the flow core manager in order that we get the specs of the instruments. Here I'm going to choose Otago, and I can choose any of these instruments. The one that I have kind of, because it takes an hour actually to do this demo full on with all of my explanations, I have actually created a saved panel. I'm going to do it on the Aurora since it's probably the most commonly used instrument right now. Well, I don't know if that's totally true. It's just you can kind of do it from start to finish. Okay, so the one thing I want to show you though is if you choose a traditional instrument like a Canto, sorry, my computer might be a little slow here. It's going to show you all the filter sets that are available on that instrument. It's the actual configuration. What a lot of people like is if you look at the print panel, it's going to give you an idea of the kind of fluorophores that actually are in that, you know, that are useful in that configuration. However, this is not exhaustive. It's really meant just to give you an idea of what's possible. I would really rely on the suggestions from the IntelliPanel. All right, so I'll say that I went to this 4 laser. It's going to take a second for it to update. These do not have the filter configurations. I'm thinking about putting it in. It would be very confusing visually for you to look at. Sometimes it can be helpful though for you to know what the peak of your fluorophore is and how it's matching to each of these channels. But you know, this is the benefit of spectral, is that we shouldn't have to think about that quite as much as we do with conventional. So I would click continue. And what it's doing in the background is thinking about which fluorophores are suitable for each of those channels. And so here I would choose what my target species are. You can see that the IntelliPanel is already toggled on if I'm in this program. You also have the ability to limit your preferred suppliers. I believe in what I loaded up, I did limit it to maybe 4 suppliers, but you just actually type it in here and you choose it. And that we hear back and forth from a lot of people, either that we're offering too much information. So really what we're focused on is making sure that we're as accurate as possible, because accuracy is the most important thing, but you're going to sacrifice either speed or simplicity for accuracy. As a scientist, I personally think that there's nothing that supersedes accuracy. So I have the ability to use a template panel, for example, any of these OMIPs. We actually tested IntelliPanel on these OMIPs to see whether or not we got lower complexity index scores. You could also choose from your saved panels here. These are all ones that I've done previously. Instead, I'm going to actually use a template panel. Oh, sorry, I want to show you one other. And also, you can actually manually type them into each of these fields. I don't really recommend that. It takes a long time, especially if you're doing like a 24 color assay. Sometimes what I use is this feature right here to add bulk antigens. And here you would actually just type them in like this. And you can see that it's finding what I'm typing in. I'm matching it to what the marker is displaying to let me know that it's actually getting the right thing. I've already told it it's human and I want to use it in the panel. So if I'm manually entering, I can either do it that way, or I can copy and paste out of an Excel or a Microsoft Word or whatever it is directly into that space. But again, I am short on time, so I'm going to go to Chameleon Demo. And what I decided to do was basically, in a demo, it's easy to do the T helper subsets because they are defined typically by a chemokine receptor and by a cytokine. I'm actually going to, okay, I'm going to apply this template. Unfortunately, it retained the fluorophores from the previous experiment, which is unfortunate. I was hoping it would just load all of my markers, but say la vie, I can get rid of them. I just have to do it manually on the next step. I tend to leave my live dead fixable open when I'm asking it to suggest. There are so many live dead fixable probes out there. And typically we can use them to be slotted into channels that we don't want to use for antigens. A good example might be one that is excited off the 633 laser and emits into, say, 520 or 570 or something like that, a channel that we don't really have a great fluorophore for. So I'm going to get to this, and you can see it accidentally restricted all my floors because I ran this before, and I want to show you it auto-populating. So what I am going to do is loading the fluorophore. I'm going to go through and actually just get rid of the fluorophores so that we can have it re-choose. From this, so what you will have seen me do here is expand this options tab right here. And in expanding that, it's going to give me my co-expression groups, my target species in case I have maybe a humanized tumor where my target was mouse, but something within that, a marker in particular, needs to be changed to human.
Kelly, can I ask a question?
Yeah.
Georgia has asked a question. She's asking if we can you save a database of fluorophores or antigens you've already put together?
Yeah, we're working on that. So the idea in the future, which I'm not sure how long this will take us, is to create iterations. So in a perfect world, what I should be able to do is create just my antigen list and have that saved as an iteration. And then be able to have it suggest fluorophores and create another iteration, and then make some changes and then create another iteration. We're actually actively working on that right now in order to institute it, because especially for spectral, panels don't tend to have one correct answer. They tend to have many potentially correct answers. And it's important that we're able to curate the suggestions. Did that answer the question, or was it a different focus?
We just want to know if you can save the database of the fluorophores or the antigens that you've already used. And
yeah, so each of those would mean that you could save it,
yeah, and
you could re-import it at kind of any stage of development of that. Hold on 1 second.
So is that an option to be able to save what you've done already and then re-import it back in and then adapt it if needs be?
You got it, yeah. Well, I think I didn't help myself by trying to re-import only the markers. So I'm actually going to.
So Kelly, we can't see your screen anymore either. So just to, Georgia, I want to clarify that question first of all. If we wanted to, if you have, for instance, a list of fluorophores that you've got, say, in the fridge, yes, we have an option to be able to list that, those like antigens and fluorophores, those products that you've got in the fridge. We do have a stock option that's available as part of FluoroFinder. Is that right, Kelly? Like you have an inventory option.
Yeah, we're trying to make the inventory a little bit more sophisticated so that it actually references and maybe eventually integrates your inventory. Right now, your inventory is it'll say that you had previously selected something, or it's a bit limited, its integration at this moment.
Okay, but we're working.
I'm gonna have to like redo this so that you can see it, but whatever, it's fine.
Okay, while you're doing that, I've got another question for you as well.
Okay, it's hard for me to concentrate on your question and type it in, but I'll do my best.
Sorry. So there's a question from Virginia. For a specific instrument that she has a spare bandpass, she has spare bandpass filters that she can change for specific panels. So basically she's got a couple of bandpass filters that she interchanges for particular panels. Do you have to have numerous instrument names to be able to use this panel builder, or can you have one instrument name with numerous filters associated?
Yeah, so what I would recommend doing is what people have to do with the Bigfoot, because there's so many different configuration potential. You can actually just load up 2 different instruments and say, this is one configuration and this is the same configuration. It doesn't actually have to be 2 separate instruments if you have the option to change up the filter, and then you can auto load it. But as an individual, we can't let, well, not we, your core facility can't let you change the machine actual on our program, or it would mess it up for everybody else. So in a way of kind of reducing, that ability to create discord, only the manager can change, but that doesn't mean that you can't add new configurations. Or also what I didn't show you was right below selecting your institution, you can choose a generic filter or a generic instrument. Anyone that's commercially available should be on there. And if you don't see a configuration on there that someone regularly uses, you can add it to it. We don't really care what the configurations are in there.
Okay, so let me just, so you basically suggest having 2 different, so the same instrument listed with a different configuration, is that right?
Mm-hmm. Yeah, I have a friend at Salk that does that. She's got one instrument that people regularly change out one of the filters, so easily you could just give them 2 different names, and then depending on what your needs are. All right, so I'm just gonna do a smaller panel than the one that I had. We'll break it since we only have like 12 minutes left. Okay. So what this is showing you is I've limited it to those 4 suppliers, Bio-Rad, Thermo, BioLegend, and Miltenny. It is telling you how many possible reagents that you have to work with, because one of the first things that it's going to do is look at any that are a limiting factor. So if you have an antigen where there's only PE or APC, you're going to need that to be assigned first, and it has to take that into account right away, even if it cascades through the panel. And so with these options, I usually do this side by side, but the most important part of this is your co-expression group. And this is also something, just like your previous question of being able to save your markers, you should be able to save your co-expression group with it so that this can become auto-populated. Like I said, this is literally the very first version of IntelliPanel. All of these will trickle out over time until we're eventually at an entirely new phase of the panel builder. So here, for example, if this is CD45, I could say that this is CD4 T cells. And then I could say this is my Tregs, and you actually just press return in order to make it go faster. And then I'm going to group all of these into the T memory subsets. But theoretically, you can load as many co-expression groups as you want, because what it's going to do is take those co-expression groups, find the lowest complexity index within each of them, from, like, I like to call it like the Russian stack dolls, where you kind of start with the middle, the ones that have the least number within them, like CD25 and CD127 for Tregs, and then you start expanding it out until the iterations that the algorithm is calculating give you the lowest total complexity index for. So these are really the only ones that I have in here. And then I know that this is going to be abundant. Eventually, antigen density will also be able to be automated, but only for normal, healthy human. Well, normal, I should say healthy. And even that, we don't want to rely too heavily on that, because I don't know a lot of people that are doing research on only healthy patients. So it's nice to give that as a background, but we don't want to rely too heavily on that. That requires some optimization. So CD3 is going to be the same. That's expressed on all of them. And then CD56 and CD19, I'm going to put into a dump channel. Because I'm putting them into a dump channel, I do need to have an antigen expression so they can get assigned to an appropriate fluor. But that's all I need. They don't go into a co-expression group. The dump channel is the co-expression group. So let me see that I have everything. I don't have any particular ideas of which clones or fluors that I want for these, although on 45, I almost always put BUV395. But for this, so CD4 is such a good example of that, because especially if you're looking at a person that is having an immunological challenge like HIV, or you've done a PMA stimulation, CD4 can become downregulated and make it kind of difficult to detect. So that's one that you would think would be a no-brainer. It's just abundant, but it's really not in most contexts. So CD8 is not a CD4 T cell, it's not a Treg, but there will be T memory subsets that are expressed on CD8. And then same here, it's going to be CD4 and Treg. I'm not going to put T memory on this one. Not totally sure if CD25 is. So these guys are low expression, Treg, CD4. No preference on clone whatsoever, although I'm really liking a lot of the Ray affinity antibodies from Miltenyi. They've got amazing validation data for their different recombinant antibodies, which I think is just stellar. I love it when people do the work for us to let us know. So 45 array is about mid. 197 is like the bane of my existence. I always put this as low as humanly possible. And in all reality, I have a favorite for this. I have a favorite clone here. So you'll see it really limited it to only one supplier because this is a BioLegend clone. And man, this is just not wanting to work for me today. I usually use this on PE Dazzle, which is definitely one of these, so I don't know why it's deciding not to show it. 185 tends to be a bit low, so does 183. I always forget, I think 196 is the low one and 194 is the mid one. Somebody could correct me on that one. These guys are all memory. Normally I would break these down into TH1, TH2, TH17, TH, but that would take us a while here. So I get done with all of that. I can kind of scroll up. A bunch of these I have favorites on. But every choice that I make to restrict the clone, it is going to reduce the number of potential candidates I have to build my panel. So it could potentially increase my complexity index because I put restrictions on. The thing I'm most proud of down here, I'm a dye chemistry person, so filling out this category well so that you can have, for example, functional reagents like calcium, pH, whatever, included in there. This is where we actually choose our viability. You can type it in as well, but I like leaving it open so that it recommends something for me. It also has permeate and impermeate nucleic acid stain. It has the full repertoire of fluorescent proteins. I could just put GFP in there to throw a wrench in it if I wanted to. And by doing that, I'm ready for it to calculate. How long this step takes, because it's looking at the total availability of all commercial reagents, it's matching it to the criteria that you've given it, and it's matching it to your instrument. If you have, say, 30, this could take you, I would say, about a minute. This one will probably take us about, I would guess, 45 seconds. We're always working on trying to make it faster, but it's accessing a significant amount of data and it's iterating that data. So it's trying to find the lowest complexity index for what I've given it. And it's not always, it's doing that over and over and over and over and over again until it decides that it has met a good complexity index. It does not always give you the lowest possible complexity index because it is only one of the many factors that it's taking into account when it's choosing a reagent or a combination for you. Any questions while we're waiting, Catherine?
Sorry, I was on mute. No. Here I am talking.
Okay, so I love this screen because I love it when it tells me how many combinations of reagents. It certainly puts some pale on me doing this in an Excel. So it's analyzed over 10 million combinations, and it's kind of giving you some guidance. It will show you the spectra right away. One of the things that I like is if you click on these little spectra things right here, it's actually going to remove that spectra so that you can isolate maybe only one of these populations in order to see what that total what that spillover visibly looks like. I would say this is just more for curation. I don't tend to look at spectra when I'm building panels. I kind of have already taken that into account. So I can toggle it off, or I can turn it into light mode. Oh, it doesn't want to do that. All right, so I'm going to toggle off the spectra viewer. What I want you to focus on here is the complexity index score. This is an amazing complexity index score, but it's also because there aren't that many markers in this panel. And so what matters more is not this total complexity score, because not all of these fluors are co-expressed. What matters is these individual scores right here. And it needs a second just to bring it up. All right, and what you're going to see here, if I expand this, are what restrictions I put on it, whether I have a particular clone, the antigen density that I gave it, and then below these little lines are telling you the brightness score that has been assigned to that particular fluor. Sometimes it hasn't made a choice yet. Those are all the UV channels on that don't even have fluors available yet. On the Aurora, but it has a ton of channels. See, so this is sort of, it kind of makes me giggle because I always put CD45 array on BUV 395, and what it's doing is actually learning from others. So if you really wanted to screw with the IntelliPanel, you would feed it a lot of gibberish. Instead, it's being fed by people like me and my cohort who are all relatively well-versed in flow, and the kind of choices that we're making are teaching the algorithm in order to make good decisions for you. I wouldn't exactly call it artificial intelligence because it's really only regurgitating the choices that we've made, and it will do that over time when it becomes amassed. There's basically a weight that is being adjusted every time someone either crosses out a marker that's been chosen and then chooses another fluorophore in its place. So this got us a lot of the way there. One way to reduce, just especially on an Aurora, because all these channels, there aren't even reagents for these, is sometimes I like to collapse it in order to just kind of see what was chosen. Eventually, when you click, this is also something that's kind of in development, but clicking on this icon right here will end up only showing you the markers that are co-expressed on that group so that you have a more reduced complexity view of everything that's going on. But these made some very good choices. I'm happy with all of these. CD25, I don't know if you've used the star brights, but they're very bright. You would not have thought that this would be quite as bright as it is. Same with, I'm sure you have experience with BB421 though. So that's usually what I do is kind of go back and forth and see what choices it's made. There's a few things I want to point out. I've already talked about a lot of the things that are used in the background to make these choices, but what's also important is that I have given weight as an expert in fluorescence applications. I, for example, will let it show you Alexa 700, but it is a fluor that's behind in the times. There are alternatives like R700 or R718, or one of my favorites, NovaFluor Red 710. Those are all far superior alternatives to Alexa 700, no matter what instrument you're on. There are very obsolete fluors that we kind of continue to use because they're available as direct conjugates, and it still is capable of allowing you to choose that. But I want it to make a choice that an expert would make. So that would be the same for a fluor like V500 or BV570. Percp Sci 5.5, there's awesome alternatives to that. I don't know if you've used the real blue and the real yellow fluorophores yet from BD, but there's just an explosion in technology that is specific for our success in spectral. So the other thing with the dump channel is there are preferences that we have in building panels for even the dump channel. So I've given differential weights to fluorophores that perform optimally in the dump channel. PE Sci 5 is a great example. If I'm not having these markers as part of my analysis, then it's okay that the dye is very bright and very promiscuous, for example. So the other thing that keeps coming up here every time that I kind of mouse over one of these options is it's giving you an idea of how all of these fluorophores are spilling into other channels. So it gives you an idea of spectral spillover. We don't give overt warnings anymore because flow cytometry is a technology that is spectral spillover. It's not for us to grade the degree of that. Sometimes we'll give little warnings that just say, hey, you should know that this has a significant amount of spectral spillover into something else. But what matters most is this. This is the quantification of that spillover. So as long as these values remain low, you know that it's not a problem. And people have always asked me regularly, is there a good complexity score? And that is not the case. However, as I start adding more and more markers to a panel, simply that value will increase because I have more fluorophores around. However, if I get to a complexity index of say 20, I will go back and say, I don't have that many parameters in this panel. What did I do wrong that I have this high complexity index score? And eventually, like I said before, you'll be able to say you don't want one of these markers, it doesn't fit you, it doesn't perform well on your instrument, and you know that. You'll be able to cross it out and say, update this panel and give me all these suggestions where this is not included as a combination. Yeah, we'll send you an email when that's ready, but it is an active project. So here I can go through and I can select products. It's going to take me to this screen where I can say I'm interested in, say, a certain size or a certain isotype, or I want the least expensive reagent, and I can sort based on these different parameters. I can add the reagent to the panel, and you'll see that it gives you a catalog number, so that when I get to the end and I have this this view of the panel in its entirety, and I can send that to my lab manager or whoever's going to do the purchasing for the lab. The other thing that I think is a lot more efficient is if you go to the product selection workflow, it's going to take you step by step through each of these markers. So you see where I'm mousing over, it gives you the reagent combination that I've chosen, and it allows me to just quickly go through with the recommendations to populate it. Some of them have, let's see, some of them have a limited number because I limited the supplier or because they're not a common antigen. Some of them will have a list of like 50 vendors and all these potential options. Say that we get to something like CD4, there's just like a million options for that. Except for that's on a NovaFluor, so that will only be one. And that's on an eFluor, so that will just be thermo. The other thing that I want to point out is, say that you wanted Spark UV387 instead of BUV385. Actually, maybe I'll do it over here. Let's see a good example. Yeah, the APC eFluor 780 is actually a really good example. there's going to be a whole bunch of different fluors that are all going to be CD4 positive. We're going to have to wait for it to load real fast. Oops, I'm going to expand it. I believe it's going a little slow because I'm presenting, because it does not normally take this long.
Can I
I
ask
feel like it's always the game.
Kelly about choosing fluorophores in the meantime? This is my personal question. Is, you know, you're saying that there is an awful lot of new fluorophores that are coming out that are better. You know, is FluoroFinder putting together some kind of comparison table where we can sit there and actually look at all the different fluorophores that are available and why they're better and what's the differences?
Yeah, so that is, I was actually just working on that this week, going through our entire database and saying which of these reagents is all the same.
Mm-hmm.
In order that you can go to the dye directory, search for APC Cy7 and find an equivalent fluor that's identical from all the manufacturers. So that's the first place to start. Doing that visually as a poster or something like that is really hard, but I could see us making a more integrated tool. Okay, so say here I wanted PE Bio 770 instead of PE Cy5 for this. All I have to do is actually click on this and it will choose it instead of the PE Cy7. So that you don't always have to go with the proprietary branded fluor that's only going to give you products from one of the vendors. I can do that here. Oh, sorry, it just took me back to the, you can see I'm on CCR6. It took me back to the panel, so the selection tool for the reagents, but you can see here that it was changed. Okay. That's kind of it for the demo. It's going to take me too long to choose all the products. But what I would do next is go to the top here. No matter what, I need to save my panel, right? You have many steps at which you can save it in case you're interrupted. But here I'm going to just continue and it's going to bring me to a summary sheet. And this is something that I can, if I've got all the products filled in, which I don't, this is something that I can print and send to, or email actually. So you can share the panel right here and you can email your results, say to whoever is in your flow core or whatever. That's kind of where we're going to have to leave it here since we're 7 minutes over. But if anybody has any questions, now is the time to ask. Or again, feel free to email me or support@FluoroFinder, and we're happy to do a demo for your institution, for example, to see how many people would be interested. The way that we handle licenses is akin to how you would handle any software license, which is just your active users. You give us a list of all your users, and then as they sign on and they use the product, they can be charged for it, and we can provide a summary of who's used it, how much, and all that kind of stuff for you to do your counting at the end of every quarter or year, however that happens. So we're trying to make it as easy as possible for you to administrate that.
So if there's any more questions, please put them into the chat or the question area. In the meantime, I'd just like to thank Kelly and Sophie from FluoroFinder for this presentation. As I said, if there is any other questions, Kelly's happy to have them, happy to be able to do it via support@fluorofinder.com, or you're welcome to email me, Catherine@chameleonscience.com as well. Thanks, Georgia. Thank you for your encouragement. And we'll be in touch following this just to see if anybody else needs some other personal support with them to help set up the FluoroFinder platform. There's
also a PDF. Did you send that out to people? Because there's a few other slides at the bottom that talk about culprits and the victims that I use in a larger talk that I thought people might find useful. So feel free to send out the PDF to whoever would like it.
So we'll be sending out the recording, and it sounds to me like we'll be sending out the PDF as well as part of that. And again, if there's any questions, please let us know. At the moment, everyone's just saying super cool. Thank you very much. No problems, Sean. And if there is, I don't think there's any specific questions, so we're probably going to end here. So to let you guys go back to your day. Thanks very much for your time.
Thank you. Have a great day.
Thank you.
Bye.